Preparation of alkanes. Number one, lab, that is laboratory preparation. All the chemicals till now we have studied. We have studied first their laboratory preparation. Here also the same thing. So we will start with laboratory preparation, in which we will take sodium acetate. This is called our sodium acetate. With this soda lime heat. So we will get CH4 plus Na2CO3. Then CH3, CH2, COONA plus NaOH, that is CaO, soda lime heat. This is called sodium propanoate, that is CH3, CH3 plus Na2CO3. Now this we have prepared methane, and this is our ethane. Okay, like this we can go on and preparing the higher series also. Here we have to notice one thing, that we have taken a carbon compound with two carbons, but we get only one carbon, that is, it is chain decreasing. Now another one point to be mentioned is this process name. The name of this process is decarboxylation. Decarboxylation, that is, D means minus. The process name is decarboxylation. Why? D means minus. Carboxylation means carbon dioxide. We are eliminating this carbon dioxide. That is why it is called decarboxylation. Now we will go on to the second process, that is not our laboratory process but another very useful process, reduction of alkyl halide. We can take any alkyl halide. Suppose we are taking CH3CH2Br, that is ethyl bromide. Now to reduce, we have to add some reagent, obviously, that is the catalyst zinc copper couple and ethanol, which will produce nascent hydrogen. This is called nascent hydrogen. Nascent means newly born, just formed. Means it is just formed, it is in the atomic state, newly born. So CH3, CH2Br. So it is nascent hydrogen. Now the thing is that this bromine goes away and in this place the hydrogen is substituted. So CH3, CH3 and HBr. Likewise, we can prepare other thing also, that is CH3Br and H plus and zinc copper couple, ethanol, that is our CH4 plus HBr. Now for class 10 syllabus, these two preparations are sufficient. These two are only in the syllabus. Then we will go on to the reactions given by alkanes, that is, this alkanes gives only substitution reaction. Alkane gives only substitution reaction. Okay. So we will move on to the reaction of alkane. So first of all, we need to know that alkane gives only substitution reaction. What does it mean? Substitution means alkanes. Mind that this is alkanes give substitution reaction. Because alkanes are saturated hydrocarbon. Because alkanes are saturated hydrocarbons. That is, all the bonds are filled up. So we will get only substitution reaction. Now, let us observe with this. First one is halogenation. Halogenation, that is, we will add some halogen in presence of sunlight. That is, we can write it as H mu or simply sunlight. So, one of the chlorine atom will come and substitute here. So, we will get CH3 Cl plus HCl. Next, if you take this CH3Cl and add one chlorine, then again sunlight, that will give substitute another chlorine. So we will get CH2Cl2 and again HCl. Then again we will get CH2Cl2 plus Cl2. That is, we will get Cl. So this is again Cl. So it is CHCl3 plus HCl. And the final one, that is CHCl3 plus Cl2, sunlight. It will again give another last hydrogen that will be substituted, that is CCl4. Now about the name of this compounds. This is CH3Cl, so it is chloromethane or methyl chloride. Then it is dichloromethane. And this is trichloromethane. And this is tetrachloromethane. This is chloroform. This is the other name is chloroform. Is the UPAC, this is the UPAC name and this is the common name. So we have completed here the halogenation of methane. Likewise, we can do the halogenation of ethane also. Now comes halogenation of ethane. Here we get CH3 plus Cl2. So it is CH3CH2Cl plus HCl. Same thing, sunlight. Then again CH3CH2Cl plus chlorine. So it will be CH3CHCl2 plus HCl. Now if the compound is like this, the naming will be 1,1 dichloroethane. Okay. Then we will move on to next one, trichloroethane and so on. Then 1,1,1 in this way we will go on. This is the halogenation reaction of ethane. And next, the second one is oxidation of alkane. Suppose we take methane and react it with high oxygen. So we will get carbon dioxide plus water with excess air. Any hydrocarbon you take, you will get carbon dioxide and water with excess air. Then with limited air, CO plus H2O. This is with limited air. And still very limited air, we get carbon plus water. Almost no air, very limited. This is called the soot. So as we go on decreasing the percentage of oxygen, we will getting lower oxygen content compound, carbon dioxide, carbon monoxide, carbon. Next we will move on to catalytic oxidation of alkanes. Likewise, we have CH4 K2Cr2O7. We know that this is a very strong oxidizing agent. So with which we should take little acid. So acidified K2Cr2O7. This is called acidified. So we will get the product as CH3OH, that is alcohol. Then we must get it as K2Cr2O7H2SO4. So again we will get formaldehyde, then we will get formic acid. So these are the stepwise oxidation product of methane. Now if we take stepwise oxidation product of ethane, so we will get CH3CHO. This is our acetaldehyde. This is ethanol. We have ethane, ethanol, acetaldehyde or ethanal, and finally acetic acid. There is a final one reaction, that is pyrolysis, which is, I don't think now in the syllabus, but previously it was in the syllabus. Pyrolysis, pyro means heat and lysis means break. Means we break the compound with the heat. CC bond will be broken. CC bond is very strong bond, so we need to heat it. So that is, if we take CH3 bond CH3, we may get, and heat is a high temperature process, we may get CH4 two times, or we may get CH2 double bond CH2 like this. But this is not so important reaction, so we will concentrate till here. Okay, then we will come to the next video for alkanes.